Okay, folks, we are starting the best part of the whole year. Trig. It's so great.
Mason, you happy back there?
Okay, so trig, if you look on the first part of your note, says it's the study of triangles. For our purposes in our class, it'll always be a right triangle, okay? When you take Algebra 2 and any other math course after this, you will see that it's not only for right triangles, but for our purposes, it will be. Someone really smart a long time ago realized there's a pattern between the sides of your right triangles, and we're able to program your calculator. So you guys see how it says sine, cosine, and tangent? Those buttons you probably never used before. So someone much smarter than us was able to program these ratios into your calculator so that we can make some quick computations instead of having to do it by hand. So we're going to learn how to use those to help solve for side lengths today of triangles.
Interesting.
It is very interesting. So we guys have to talk about what are these ratios. Do you guys remember what a ratio is?
Yes.
What is a ratio?
A comparison between two things.
Yeah, that's
Two lines.
right. You're just comparing two sides or two things. In our case here, those two things are sides of our right triangle. So we have the sine ratio, cosine, and tangent. All right. And they're always going from a specific angle, one of your acute angles in your right triangle. And we can see that we're going from angle A. So everyone, will you mark angle A for me on your picture? So when you do that, or when this happens, we can label our sides with respect to that angle. So we have the hypotenuse. What side is our hypotenuse here?
Probably C.
Right, the one across from the right angle. So will you guys label that either with an H or height? I always use the word height. But however you want to label it, so you know it's the hypotenuse. And then we have an opposite side, and that's across from your angle. Like it just goes through your triangle. So that'd be side A. That's your opposite side. And then we have an adjacent side. You guys know what the word adjacent means? Doesn't mean equal to. Does anyone know what adjacent? If you're adjacent to something, you're next to it. So like, do you guys see how this side here is next to your angle? It's attached to your angle. So this is your adjacent side. So you're always going to be labeling the sides of your triangles because that tells you what ratio you're going to use. So now the sine ratio uses the opposite length over the hypotenuse. So I'm going to write that here. My opposite length over hypotenuse. Your sine ratio is opposite over hypotenuse. Now if we look at our diagram, our opposite is, if this was like a number, it'd be A, right? A over, what's your hypotenuse length?
C.
A over C. This will make more sense when we have numbers, but just for this generic example, it'd be A over C. Your cosine ratio is your adjacent length over hypotenuse. So I'm going to write adjacent over hypotenuse. Your adjacent side over your hypotenuse.
B over C.
I agree. B over C. And then the tangent ratio is your opposite leg over adjacent. So if we look at our picture, what's your opposite leg? A. Your adjacent is
B.
Perfect. So now we're just going to get really good at writing these ratios. And like I said, a smart guy a long time ago figured out no matter how big or small your triangle is, as long as you knew the angle measure, it would be the same ratio. So that's what your calculator knows that you don't have to memorize, all right? So here we go. It says express each ratio as a fraction and a decimal to the nearest hundredth. How many decimal places is a hundredth? 2. Okay. Let's do this left column first. What angle are we going from? P. So mark angle P. Now we're going to label our three sides. Let's do the easy one first. What's our hypotenuse? 17. What would your opposite be?
15.
Right? I'm going to go through my triangles on the opposite side, so opposite. And then your adjacent would be 8. It's next to your angle, it's attached to it, right?
Okay, will they change the view then?
Mm-hmm. So sine was what two legs? The sine ratio. Opposite and hypotenuse. So that would be what? 15 over
8. No, 17.
17. Can I reduce that? Nope. So I can't reduce it, so I'm going to rewrite it in the slot. And now you just simply type this in your calculator, guys. What is 15 divided by 17? To the nearest hundredth.
0.9.
2 decimal places. 0.88. Perfect.
And what's the times?
Okay, cosine is what two legs? Adjacent and hypotenuse. What do we label as adjacent? 8 over 17. Can we reduce?
No.
Nope, that one can't be reduced, so I'm just going to rewrite it. And now we're going to calculate out what 8 over 17 is. 0.47. And then our tangent is what two legs?
15.
Yep, opposite over adjacent. So 15 over 8. Can we reduce 15 over 8? No. What's 15 over 8 as decimal?
8.
Would be 8 if we go to the nearest hundredth, right? So at 5 would make it go 8, right?
Yep.
Okay. Okay, now what's different between these three and these three examples?
Change the opposite of the adjacent.
Different angle. Right? Now we're going from Q, so we do have to erase because that's going to change our sides. Now we're going from Q. So now what side's opposite Q? 8. And which one's your adjacent? 15. Okay, I'm going to let you guys try to write those ratios and we can compare, okay?
Hypotenuse.
Yep, hypotenuse is always going to be across from that right angle, so that's not going to change. We match? Is that okay?
Oh, yeah.
Maybe this one? No. Let's write this for against this one.
Okay, now we're going to do the same thing, but with our special right triangle that we worked with, was it last week, 2 weeks ago? So it says use special right triangles to express the given ratio as a decimal to the nearest hundredth and a fraction. So we have the sine of 30 degrees. So let's draw a 30, 60, 90 in that space provided for you there. I seem to always draw mine this way where my 60-degree angle's in the bottom, but you can draw it really however you want. There's your triangle. Now you want to make it as easy for yourself as possible. So I'm going to make my short side just 1. That's the smallest whole number I can have for a side length, right? So if your short side is 1, what's your hypotenuse? 2.
You gotta double it.
And then your long side would be
1 square root of 3.
1 square root of 3. So I'm just going to call it root 3. Okay? So now from here we want the sine of 30 degrees. So we're going to mark the angle 30 because that's the angle we're going from. Now what legs are this is the sine ratio? Sine is what? 2 legs. Opposite hypotenuse. So which side's my opposite?
1,
1. Which one's my hypotenuse?
2.
So if I write that as a fraction, 1 over 2, right? Opposite over hypotenuse. Can we reduce this?
No.
No. So there it is as a fraction. What is it as a decimal? That's it. You did it.
Wow.
Okay, now we're doing tangent of 45. So let's draw 45, 45, 90. So what would be the smallest whole number of a leg length we could have? 1. Our legs are the same. And then this would be root 2. Yep, perfect. So we want the tangent of 45. So I'm going to mark 45. What's the tangent ratio? Opposite over adjacent. So which side's my opposite? 1. What's our adjacent? 1. So 1 over 1. What does that become? What's 1 as a decimal? 1. Perfect. You want to try the next one on your own? See how it goes? You guys get root 3 over 1,
Yep.
which is really just root 3. Perfect. I don't remember what that is as a decimal. Though. What's root 3 as a decimal?
1.7.
1.7. Go to 3. I think it has to go to 2 decimal places.
Yeah.
Is that okay? Okay, try the next one, but you're going to have to fix it because you might end up with a radical in the denominator. See if you remember how to fix it. Is this what you guys had? But then remember, we can't have a radical in the bottom, right? Do you guys remember how we fix it?
You multiply by 2.
Yep, multiply by root 2 over root 2. So we go across, remember? So what's 1 times root 2? Root 2. What's the square root of 2 times the square root of 2?
4.
Square root of 4, which is really 2. What do you guys get as a decimal for that? Yeah. Perfect. And we just have 4 left on the top of the next page, okay? 4 left. All right, so our job is to figure out what the variable is using a trig ratio. Round our answer to the nearest hundredth. So where is x? An angle measure or a side measure?
Side.
Side, okay, that's good that we can know, figure that out. Step 1, mark your angle. Mark the acute angle they give you. And now from here, we have to label the sides of our triangle. But I only label the sides that we know something about to make it easier to figure out which ratio we're using. So what is x with respect to 25?
Opposite.
Opposite, so I'm going to call this opposite. What's 18? Adjacent. Now you could label your hypotenuse, right? But do I know anything about the side length here?
Nope.
So I'm not going to label it because it's not going to help me. So now you're thinking, what trig function uses the opposite leg and the adjacent leg? Tangent. Some of you know that already, but there is this mnemonic device up here that can help you. Have you guys heard of SOHCAHTOA? Anyone ever heard that? No. Okay. So your sine ratio is your opposite leg over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is the opposite over adjacent. So maybe that's something you want to write at the top of your paper on your homework. It's up to you. That's honestly how I learned sine, cosine, and tangent to help me remember which one goes with what when I was first starting. But you guys are right. The opposite and adjacent leg is your tangent. So we're going to go tangent of our angle of 25 equals. Yep. Now we want our opposite leg over adjacent. So x over 18. Now it's just like a normal equation. It just looks a little different right now. How are we going to get x alone? How do we get rid of this 18? Yeah, we're going to multiply both sides by 18. So then this side becomes 18 tangent of 25. And then those 18s cancel out, so equals x. And now you truly just type this into your calculator. 18 tangent of 25. And if you're not getting 8.4, wave me over because your calculator might be in a different mode, okay? So if you're not getting this, wave me over.
How'd you get?
You say it might be easier?
Yeah.
Yep.
Yep.
18.
Yep.
Cody.
Yep, so you have to type everything backwards and you misclick it or you can go online. It's up to you.
What's this one?
Tapes on yours and then hits.
Huh?
25.
Hypotenuse. And then
Times.
this is like opposite, right?
Anyone else not get 8.4? Yep, so you're gonna go and then where it says right there, we'll just scroll over so it says
No.
He's touched me, teacher.
and now, yeah, now we can get out of
That
this.
doesn't work.
Now,
Say that. Never.
We'll do
I still want
those.
to get into
Anyone else not get that? You're okay? Okay, let's try another one. All right. Do you guys remember what step 1 was? What do we do first?
Label the angle.
Yes, mark your angle so we know where we're going from. And then what do we do to our picture?
Label it.
Label our sides. So what is 15 with respect to 70? Adjacent. What's our hypotenuse? Or x is our, sorry, spoiler, hypotenuse. Okay, what trig function uses adjacent and hypotenuse? Cosine. So cosine of your angle equals
15 over x.
adjacent over hypotenuse. Perfect.
Do you multiply by 15?
I know this one's kind of goofy, right? How am I going to get rid of this x over here? Right now I'm dividing. How are you going to do divide by x?
Multiply.
by x.
Going to multiply by x.
Oh, bro.
Yeah.
That's crazy.
So x times the cosine of 70 equals 15.
What? You just flip off the x and 15. What? Yeah,
Well, right, so the thing, cosine of 70 is just a number that's already programmed into your calculator. So this is just a number. So if I can multiply by this, what else can you do to it? Divide. So now we can divide by the cosine of 70.
X is 15.
X does not equal 15.
Ah.
So now you do 15 divided by cosine of 70.
Do you want? Don't touch my back, buddy.
Yeah, you should be getting 43.8.
Yeah.
They were going to 2 decimal places, right, though, you guys?
8,
So 8, 6.
Yeah.
So you have to type everything in like really backward.
The next one is.
Is that okay? All right, on this one, mark our angle. What side is 12? 12.
What is that?
Opposite.
Sure. 8, 6.
What's x? Hypotenuse. What trig function uses opposite hypotenuse?
Sin.
Yep, the sine function of 63 equals 12 over x.
Cookies. Listen.
13.47 maybe? Yes.
Probably.
Here's for the last one if you haven't.
This one's this one's got bird, bro. It's 37.
Very last.
What is that?
Hey, remember in seven?
I was like-
I didn't know.
Mary!
Yeah, we're glad.
I thought it was Mason.
Stefan, this is 2 times now.
No, it was not me.
Us to this school.
Yes, because I can smell it. It's
You have brought us to this school twice now.
It's not me.
I still plan to Tyler, get out. Someone's trying to cast us. Stefan crop dusted again. It was definitely you guys. I'm sorry, but I got a side. I changed my mind.
Didn't this happen not that long ago, right? Or am I making that
Yeah,
up?
it was Stefan's fault.
I thought it was Merrick's.
No.
Yeah, it was very
Stefan.
You just were married. Hey, there is no off and adjacent.
Well, I bet I
Yes,
changed
there
my
is.
mind again.
Which one's off and adjacent?
None of them.
Yeah.
And
Tangents?
Don't forget.
oh, that's A. Idiot.
Oh.
I thought it was
Someone cracked the sewer door with it.
Yeah.
God, or someone put the window open.
Can you stop?
Isn't it 5.09?
I don't remember.
Yeah,
Yeah, 5.09. All right.
Can we leave the class?
I will scope out the lay of the land out there.
Can we evacuate?
Can we go home?
It's probably bad everywhere. It's not just in here. It has to be bad everywhere.
You know what's
Why would you do
It's literally a sewer.
that? Stefan, it was literally you.
36. Your angle's wrong.
Oh, it's okay now. You get.
Oh, wait, kids, that way went this way. I saw it first.
You'll get used to it, Stefan.
Hey, Mark. Let's figure out how to put it together. Die. Tell me. Is he allowed to leave?
No, you guys gotta sit in your spots.
Yeah, go in the
No,
hallway.
no, you gotta sit in your
No,
spots.
I can't.
Well, that's scary. Buddy.
You need to learn.
Don't
to
talk
just-
to me.
You want
Don't talk to me. Don't talk
together?
to me. No.
But-
See you later.
Wait. Can you please resolve the conflict? Me? Me? Why? Hey, why don't you have plans for that? You just.
Are we in Hunter on the hall?
Then I'm gonna taste it.
There's a big purifier.
I can never do that here.